And hello guys, welcome back again to the math lesson. The topic is still the matrix of grade 12 Euclidean geometry, but we are still moving forward with the topic. So now we moved to something new. Okay, but still, if you understand the proportionality theorem, you definitely will understand what this topic is about. So this topic is about the converse of the triangle proportionality theorem or the converse of proportionality theorem of the triangle. It just depends on how you want to say it. So this is the converse of theorem 1. Remember what theorem 1 said. So theorem 1 say we are given a triangle like this. Triangle A, B, and C. You will be given a triangle and you will also be given some parallel lines such that there exists some line there in the middle of the triangle or anywhere maybe in a triangle such that that line is parallel to the third side of this triangle. This is what you were given in a proportionality theorem, and you were required to find maybe some sides or some ratios that are equal on this triangle. So now, with the converse of that theorem, we are just reversing the things. Now, you will be given the ratios of these sides, or you will be given the lengths of these sides, and then you will create some ratios to now show that these lines are parallel. I hope that makes sense to you guys. So now let's dive into this business of this lesson. So now let's go to that statement that is being stated by this theorem. They say if a line divides two sides of this triangle, there is that line, and we can see that this line divides two sides of this triangle. So it divides them proportional. Then that line is parallel to the third side of this triangle. Fine. Now, let's say in this triangle ABC, you are given that you have the ratio on this side that AP over PB is equal to AQ over QC. Or you can just play around the proportionality theorem, just like you did before. You can say now AP over AB is equal to AQ over AC, or PB over AB is equal to QC over AC. Now, if you are given that, you can conclude now by saying PQ, which is this line, is parallel to BC. So now I want to come emphasize this. If maybe you see some line this, and then A, B, C, oh no, I want it to be like this. A, B, C, A, B, C, let's say D and E. In this case, you can't just come to this diagram and tell yourself or tell your friends that, oh, this line DE is parallel to this line BC. Why? Because we deal with reasons here. If that friend of yours is asking you, why, Chomi, do you say line DE is parallel to BC? What will you say after she or he asks you, why do you say those lines are parallel? You won't have a proper reasoning behind that unless you are given that the ratio of this side is equal to the ratio of that side. Then now you are convinced that indeed this line is parallel to that one. Only if the ratio of this side is equal to the ratio of that side. I hope that makes sense. So now let me continue with the theorem, okay? Now, like we said, let's say you are given that the ratio of this side is equal to the ratio of that side. You are given that. You can conclude that PQ is parallel to BC. What is the reason? The reason is line divides. This line divides the two sides of this triangle in proportion. or line divides two sides of a triangle proportionally. It's up to you how you want to say it out. Okay, let's move. Now, corollary theorem or midpoint theorem of this Converse thing. They say a line drawn through midpoints of two sides of a triangle is parallel to the third side of the triangle. Now, let's say we have this triangle A, B, and C here. Okay. And then I draw this line such that this line bisects AB and also bisects AC. Do you guys still remember what did I say bisect mean? Bisect mean, if I say this line bisects AB, I mean that now this line will be cut into two equal parts. Therefore, this part will be equal to that part. And this point right here will be the midpoint of AB. We come to the other side. We say this line bisects AC. I mean now, this will be the midpoint of AC. And then now, this part will be equal to this part. So now, when a line drawn through the midpoints of this line, automatically this line will be parallel to that one. I hope this makes sense also. Now let's move to the example 5 and see how we can apply what we have learned from this Converse and how can we apply that here in this example. So they say here in the sketch alongside, this is the sketch, AP is 12 units, okay, PB is 8 units, AQ is 15 units, and QC is 10 units. Now, prove that PQ is parallel to BC. What do you think? How do you guys think we can tackle this one? Okay, we are given the length of this size on this side, AB. We are also given the length of this side on the other side, AC. I mean, you can just write your ratios and see if maybe they are equal. If they are equal, those ratios of yours, then indeed PQ is equal to BC. Then you state your reasoning that the line PQ divides the sides of this triangle proportionally. So now let's see. This is the solution to that. They wrote the ratio AP over PB, which is 12 over 8. And then it gave them 3 over 2. Okay, fine. Now you don't state the reason. Okay, fine. And then you go to that other side because we took it from there up to this part. And then from here to down there. You would also do the same thing also on the other side. You take it from up there to the middle, from the middle again to the bottom. Okay, then what is AC AQ over QC? And then it gives me 15 over 10, which is still 3 over 2. Now, you can say AP over PB is equal to AQ over QC. Why? Because they are both equal to 3 over 2. Therefore, now you can simply say PQ is parallel to BC. Why? Because this line PQ here divides the two sides of this triangle proportionally. I hope this makes sense to you guys. Okay, let me move to the next example. Here, example 6. They say in the sketch alongside, we are given that AB is 9 meters. Here is AB, it's 9 meters. And we are given BC as 6 centimeters. Now we are given something that can be scary to some of you guys. And you shouldn't be scared of these things. I mean, we did something similar to this in previous lessons on this other example. So here you simply divide by AE on both sides, AE, so that you'll have something like AD over AE. Now you have the ratio for AD over AE as 3 over 5. Isn't it? It is. Yes. Now let's see what we are required to do. We are required to prove that GD is parallel to FE. GD, here it is parallel to FE. What can we do now here? Okay. Now, we come to this triangle, guys. Okay. And in this triangle, we can see that we are given that this line is parallel to that line. What can you say about that? If we are given a triangle with some line that is parallel to the third side of this triangle, then proportionality theorem is applicable. Therefore, now in this case, you can say AB over BC is equal to AB over BC is equal to AG over GF over GF. They are both equal to 9 over 6. Okay. Okay. And then why do I say this? Okay, let's simplify that. This will give me 3 into 9 because the 3 times 3 into 6. I have 2 here. And then now, why do I say this is equal to this? Because I use the proportionality theorem. Why? Because VG is parallel to CF. Okay, perfect. Now we have this ratio here for this part over this part. And then I also have something here. Let's use this information. I have the ratio AD from here to here as 3. I have AE there as what? As 5. Fine. Now, can I get this? I can. What is this? It's 5 minus 3. This is going to be 2. Okay. Now, clearly we can see that the ratio AG over GF is equal to the ratio that side AD over DE. Yes, now they are both equal to 3 over 2. We have 3 over 2 here. We had 3 over 2 right there. So now you can say this line GD is parallel to FE. GD is parallel to FE. Why do I say this? Because there is a line right there, GD, that divides two sides of triangle AFE, proportional. Then you are done. You have proved that these lines are parallel. I hope this makes sense to you guys. Then let's move to the next part. Give example 7, okay, which is the last one of this lesson. Example 7, when we look at this one, they say in the sketch alongside, which is this one, we are given that PS is parallel to BR. Therefore, if this line is parallel to that one, clearly you can see that a proportionality theorem is applicable on this triangle ABR. Okay, and SQ is parallel to RC. Therefore, that simply means ARC triangle. Then proportionality theorem is applicable on that right angle. Okay, now we are required to prove that the line PQ is parallel to the line BC. So with this one, I will just simply explain this solution of theirs here. It is still simple to just explain it from here. So we have AP over PB in this triangle. That is equal to AS over SR. They are equal. Why? Because I use the proportionality theorem since this line is parallel to that line. Okay, perfect. That's what they did here in this step. Fine. Let's go to the next one. Now, we have the ratio here. That ratio AS over SR here is equal to the ratio AQ over QC. Why? Because proportionality theorem is applicable here since SQ is parallel to RC. That's what they did here. Fine. Now let's come to the conclusion now. Now this ratio AP over PB will be equal to the ratio AQ over QC. This is what they hold here. Why? Because they are both equal to AS over SR. They are both equal to AS over SR. Okay, fine. Now, if this ratio of this side is equal to the ratio of this side, then we can come to the conclusion that this line is parallel to this line. Why? Because this line divides these two sides of the triangle proportionally, or they divide those sides in proportion. Thank you guys for the lesson. We will meet again in the next lesson.